each mobile developer knows that one of the most battery draining features is location tracking. Actually, it's not only about the device battery itself, but also potentially about lots of traffic to transmit, to data to store, to process on the cloud, and so on. So it's crucial to use this as a potential for optimization as such resource-consuming for such resource-consuming operations. Hello, everyone. Super excited to be here again. So, sustainable mobile apps, right? But before we begin, for those of you who don't know me yet, let me introduce myself. I'm Jane, and I've been around the block for more than 10 years now. You can say so by gray hair on my head, but I've started my career as right where many of you are right now, coding and creating things. But since I currently mostly focus on managing and leading a brilliant team of 50 mobile developers, guys, I know you are watching me or will be watching, so hello. Right now I'm more focused on management and on making our processes smoother, on collaborating with our business development team and stuff like that. One thing to mention is that we at Nix, the company I work for, we don't work on our own products, but we help our partners to build and support their digital solutions. So it means that day to day we face a lot of domains and a lot of business use cases. So when I'm not working, I love to recharge by freediving and hiking. And one little tip for you: if we met in person, don't ask me about freediving unless you don't want to talking about it for hours, because I really like to talk about it. So I warned you. One more thing to mention before we start is that while sustainability is a broader term, today we're going to mostly focus on the part that's most relevant to software development. Global warming and impact of greenhouse gases. So I'm going to be frequently using the term carbon, which represents all the emissions and activities that impact global warming. The primary source of carbon emissions stems from burning the fossil fuels. So why do we burn them? To generate electricity. Even we as humanity strive for green energy. Current technical and economical constraints, they unfortunately prevent us from switching to green energy and eliminating high carbon sources entirely. So therefore, when we connect device to an electrical outlet, our hands are clean, but it doesn't mean that electricity is really clean. In this context, electricity can be considered as proxy for carbon. And for a long time, again, we as humanity focused only on, optimizing physical and making physical stuff like refrigerators, cars, light bulbs, more energy efficient, overlooking the software's role in climate change. But recently, we've realized that software not only drives hardware, but actually controls it. Take a look at, GPS app. If it updates your location too frequently, or if it doesn't stop when it's not needed anymore, it will waste energy and increases carbon emissions unnecessarily. So everything is connected, and every small change can make a big difference. And bringing sustainability into tech discussion encourages people to speak up and drive a change. So moreover, sustainable apps, typically they perform better and are more resilient. And of course, these benefits are significant and added advantages, right? But it doesn't mean that sustainability is not valuable in its own right. So motivation to build green software, I hope, is clear. But before doing so, we need to answer 3 key questions. So what practices will help us? how do we measure their impact, and how much time should we invest in sustainability. Yeah, we already aware that green software is carbon efficient software that maintains the same level of value for your users while emitting fewer carbon. According to Green Software Foundation, which unites prominent companies and individuals in their desire to create green software, there are only 3 actions that effectively reduce carbon emissions associated with software. It's energy efficiency, hardware efficiency, and carbon awareness. And these principles are, more like a vector. They are stack agnostic, more like a mindset. And today we're gonna look at each of them and discover their potential in reducing carbon for mobile apps. So first principle is carbon awareness. Carbon awareness is doing more when the electricity is cleaner in the electrical grid and doing less when the electricity is dirtier, meaning when it's generated by fossil fuels rather than low carbon sources like wind or solar. So example of such technique, for instance, is shifting computations between hemispheres to take advantage of longer sunlight hours during different seasons, for example. While carbon awareness is vital and has really big impact for environmental goals, it's not directly applicable to mobile apps due to limited control over users' devices and their charging times and locations. So next principle, energy efficiency holds greater potential for sustainable mobile development. So if our aim is carbon efficiency, this inherently includes energy efficiency, as energy, as we already know, is a proxy for carbon. And this entails minimizing energy consumption per unit of work. In terms of data centers and clouds, energy efficiency is largely connected with, for example, maximum server utilization and avoiding idle states. But when it comes to mobile apps, scenarios of using our mobile devices are completely another. So the best things we can do here is to minimize unnecessary operations, renderings, API calls, etc. And we're gonna go through some practices that will help you. Some optimizations are already done by system, but other are, of course, our developers' responsibility. Of course, there is no silver bullet, and each solution needs to be tailored based on your specific business needs, your specific use cases. But there are still some standard practices that I hope will help you to find your vector in sustainable mobile app development and will inspire you today. I hope so. So let's go through them, some of them. Each mobile developer knows that one of the most battery draining features is location tracking. And actually, it's not only about the device battery itself, but also potentially about lots of traffic to transmit, to data to store, to process on the cloud, and so on. So there are multiple business use cases that require knowledge about user location, but each has its own demand on its update frequency and precision. So it's crucial to use this as a potential for optimization as such resource-consuming, for such resource-consuming operations. Classical example, classical situation when your product owner comes to you and says, okay, we need constant location tracking. Could you do so? And in my opinion, the only right answer is, and why do we need this functionality? Like for example, to understand if user is near to our offline shop to send him some discount coupon or something like that. But the thing is that for such case, you don't need constant location tracking because you have great geofencing feature that is actually optimized on hardware level. And this feature triggers the app only when user comes in or out of specified region. And it's just only one example because actually you have, again, there are a lot of business use cases and great potential to optimize location tracking in other ways. So in each particular business case, you should consider such things as reducing location accuracy, registering for significant change updates only, tracking only if specific activity happens, like automotive activity or fitness activity, again, depending on your business case. And this will allow you to keep balance between energy effectiveness and business requirements. I'll give you an example from my experience. We had a client who wanted to build a location-based social network. So the main idea was to find a pole near you and grab a beer or have a walk. And he already had a code base. And let's say he was concerned about its quality. And we also were concerned about it. And one of the main concerns was that the app drained the battery like crazy. So we began our discovery to find out the most significant causes of the issue. And among, of course, some other things that didn't work in most optimal way, we found out that the app tried to update location with the best accuracy and the best frequency that was even possible. But it was not actually needed to align with business requirements and to understand which users are within walking distance from you. So just by tweaking two parameters, tracking precision and frequency, we decreased the impact on the battery by 2 times. So location tracking is just an example of how knowledge of your platform and API that platform provides for you as a developer lets you achieve a lot of goals, not only save battery life and make mobile solution more energy efficient, but at the same time, the user experience becomes better when you apply such techniques. No one likes actually apps that drain battery or trigger high bills for mobile data usage. And third, bonus, it prevents unnecessary data transmission, storage, and processing by conducting initial data processing at the very source. So the final point introduces us to another big topic in optimization is mobile network optimization. Of course, it's obviously that performing network operations in app incurs energy consumption and it costs energy. This is because network hardware like cellular and Wi-Fi radios need to be powered up for the operation and stay, which is even more interesting, stay active for some time after. And it, of course, drains battery. And several factors influence energy consumption while you are performing your requests to the server. For example, cellular networks consume more energy compared to Wi-Fi, and also weak signals and limited bandwidths lead to prolonged radio activity and are bad in terms of energy efficiency. So how do we practically can consider these facts to make our networking better? Generally speaking, here we have 2 strategies for optimization, minimization and deferring. As for minimization, we typically consider caching and compressing transmitted data, as well as decreasing media quality and file size, if possible, of course. This choice can be made by user or implemented automatically. An illustration of this concept is video conferencing software that dynamically adapts streaming quality. So instead of streaming at the highest quality possible at all time, it reduces the video quality to prioritize audio when the bandwidth is low or if the cellular connection, if the phone is on the cellular connection. So this feature is typically also activated when your phone is in low power mode. Actually, this is only like one example when the solution serves not only sustainability itself, but also the user experience, because of course, obviously it's much more important to hear people you talk to rather than like seeing their picture perfect portraits, but with delays and with no sound. Another networking optimization strategy is to defer it. First things to consider here is to batch transaction. So downloading content incrementally keeps the radios active almost all the time. constantly, and it's resulting to energy wastage. Whenever feasible, your application should consolidate network operations. Like, for instance, if your application serves ads, consider downloading them, like a bunch of them, multiple ads in one go, and then displaying them gradually over the time, rather than downloading them as needed. So often it's a great opportunity for optimization to delay network operations. Here in a serial session, deferrable background sessions may help you if you want to upload or download something, as they allow easily to delay requests and wait for for the most optimal conditions when phone is charging, when it's on Wi-Fi, and so on. So these may come in handy for such functions and features like backups, for example. Last but not least, to emphasize once again the significance of limiting network activity to Wi-Fi. Of course, it doesn't mean that you won't do anything on cellular connection, but for instance, don't download high-quality video over cellular connection unless user explicitly requests it. Because such actions can waste bandwidth and may even result in, I don't know, high bills for your user, which is not really cool as well. So switching to another topic. As I've already mentioned, when it comes to server, in terms of energy efficiency, it's important to avoid idle states and to utilize server at the maximum. An idle server has a carbon cost for both embedded carbon. We'll get back to the term embedded carbon a bit later. So it costs both for the embedded carbon and its insufficient utilization. But we can't avoid idle states for a personal device, so our main goal here and our mission is to ensure that this state isn't interrupted without need, because waking up system from the idle state consumes energy because it involves waking up the CPU, all their other components from their low power modes. So work less on background and don't try to fool the system, like, I don't know, playing silent audio in the background, never in a million years. And also use timers wisely, meaning that you should specify suitable timeouts and, of course, invalidate right after you don't need timers anymore, and you need to be pretty attentive to do so. Actually, talking about timers, frequently apps implement them while they're not actually, there is not actually necessity in it. In many use cases, instead of relying on and focusing on fixed time intervals, it's better to use event notifications from system-provided services, of course, if they are provided and if they are available. Next topic, things to remember when you work with notifications. So first, you need to, again, whenever possible, to use local on-device notifications to reduce strain on network hardware. And second thing is that remote notifications, if you need to use them, they provide several push priority levels, from immediate delivery to delaying delivery until energy efficient time. So unless notification genuinely needs to be delivered immediately, please consider and opt for deferred delivery priority. Next topic is about energy-wise design considerations. If your app uses standard views and controls, likely you won't be too concerned about its UI efficiency. However, most real-life apps want to stand out, want to use some eye-catching design, something fancy. So there are several things to keep in mind to ensure energy efficiency. First, remove drawing when you're up and ensure that you do it when you're up and its content is overlapped by other views, cropped or off-screen. So remember I told you about those location tracking driven social network. So one of the crucial optimization we've also implemented in this legacy code was reconsidering the map screen. Initially, when user opened it, the phone was heating up so much that you could try egging it, and it was because the app was trying to show hundreds of pins on the map. Not only was it too much for CPU, but also for the user because the screen was too cluttered and hard to operate with. So just by implementing proper clusterization, we saved battery life and again made the application much more usable. Next thing, reduce the opacity, the use of opacity. I know it can look beautiful and it looks beautiful, gorgeous, but it costs much. And like particularly views that use translucent blur effect. If you must use opacity, don't use it, at least don't use it above the content that changes frequently. We can consider implementing of dark mode in apps just as a tribute to trends or just as a feature, but actually, in fact, it has a deeper meaning for saving smartphone resources since it reduces screen brightness. According to different researches and different benchmarks, transitioning from light mode to dark mode can result in around 40% reduction in power consumption, which is true for modern devices and of course, it depends on design peculiarities and screen brightness, but still the fact that dark mode is good for your battery life. Last thing I want to mention, talking about energy efficiency of mobile apps, and I know I'm talking on at iOS native developers conference, and answer to this question may be obvious for a lot of you, but when you work with different customers with their different goals, requirements, restrictions, and you need to align with different budgets, development time, technology compatibility, different teams. So the answer is not so evidently what to choose here. But however, in terms of sustainability, native development for sure is a better option, as native apps are still much more optimized for target platform, and they doesn't rely on additional layers and bridges as cross-platform apps do. Devices produce carbon emissions throughout both manufacturing and disposal phases, so not only when you use them. And for some devices, actually, the carbon emissions associated with manufacturing can be much bigger than those that were created while you were using these devices, resulting in a much larger embodied carbon. So this is the actual term for it. So this is actually the case for end-user devices like phones, tablets, where production, upstream transportation, and disposal processes account for around 3/3 of emissions. So while certain companies like Apple have taken steps forward carbon neutrality with certain devices models, I'm talking about like special editions of Apple Watch, this is still more like an exception rather than rule in the market. So we need to consider that as well. In this perspective, hardware represents carbon, and since our objective is carbon efficiency, optimizing hardware efficiency becomes critical. And for end-user devices, this means extending the hardware's lifespan. So the longer user uses his or her phone, the better is for the environment. That's why our software needs to run smoothly, not only on the latest device models, because when hardware fails to handle current user demand, it's often decommissioned. And while hardware inevitably runs out, of course, over the time, developers can at least construct such software that doesn't push its limitations unnecessarily. And yes, sometimes it's connected to the fact that you can't use those new fancy API right away. in terms of compatibility, but at least now you know that it has some deeper meaning. The next thing I want to cover is answering the question of how we can measure impact of previously described or any other actually practices. There are several frameworks that will allow you to do that if you need to do so. Actually, it's more like theoretical part. So the Greenhouse Gas Protocol is a widely recognized framework for measuring, managing, and reporting greenhouse gas emissions. The GHG is a protocol that measures total emissions. So to calculate overall software carbon emissions, you need detailed data on energy usage, carbon intensity, and the hardware on which the software actually runs, which is hard to find out sometimes. And it's even harder if you rely on some dependencies because you don't have such visibility level. It's crucial to note, however, that the total is only one indicator that provides insight on a specific feature. And there is another framework that was proposed by Green Software Foundation. It's software carbon intensity specification. It's a methodology to score a software product along a sustainability dimension. So while the GHG protocol measures, again, total emissions, the SCI determines emissions rates. In automotive technology, the SCI is similar to, for example, like kilometers per hour measurement, whereas the GHG protocol is concerned with a car manufacturer's entire carbon footprint and for all the cars that were produced each year. So SCI score will drop if your application is more energy efficient, hardware efficient, or environmentally conscious. To determine your SCI score, you need to decide on software component to consider. So it's not obligatory for you to measure the whole app. You can pick some component or several components. Then you need to pick a functional unit, like users, for example, that defines the how your app scales actually, and measure emissions directly or use a model. You can provide several measurements and SCI scores for an app. For instance, a streaming app might look at carbon per minute or per user daily. Sustainable practices, as I said, help to reduce the score. So the lower the score is, the better. Building eco-friendly software doesn't necessarily cost more than traditional development methods. And of course, you may upfront some expenses like setting aside time for code refactoring for better sustainability. But of course, it's obvious that initially this initial investment over the time will lead to bigger benefits, not only sustainability itself, but it will make your app more efficient, easier to maintain, and so on. So adopting green software practices can help companies in marketing as well, so or attracting investments, because nowadays it becomes crucial and key factor for such negotiations. And additionally, for developers, according to some researches, a lot of developer respondents said that while they are considering to apply for a job, they also consider such factor as sustainability practices of employers. So for your company, this commitment can be a great factor to attracting great minds and talents. So while we haven't addressed every possible strategy, I hope now you have at least highlights and insights on why mobile app sustainability matters and some considerations on how to achieve this goal. So it was a pleasure to be here on stage today. Thank you for your attention.